All right, number 3, we want to actually find all the zeros of the polynomial. This could be quite a process, especially if you have a long list. In this case, it doesn't look like we'll have a really long list. Our problem is 2x to the 4th minus x to the 3rd minus 5x squared Now there are other methods to kind of simplify and shorten the list, but for right now we're just going to do it because the list won't be too long. I am going to take constant term divided by leading coefficient. We're going to remember plus or minus. We're going to list the factors of 2, just 1 times 2. Same thing on the bottom. And we're going to divide everything on the top by the divisors. So this will give me a positive or negative 1, positive or negative 2. So 1 divided by 1, 2 divided by 1. And then 1 divided by 2, get a half. 2 divided by 2, we get 1, which we already got. So this is my list. We got 6 potential numbers. Okay. Now we're going to be using each of these numbers in synthetic division. Okay. So I'm going to use a box number, and it doesn't matter where you start. I'm going to start with 1. And then I'm going to list the coefficients. So we got 4, 3, 2, 1, 0. All of the terms are there. So I'm going to bring down a 2, negative 1, negative 5, 2, and a positive 2. And we just have to guess and check. What will let us know if it's a 0 is if the end result is a 0. So 1 times 2 gives me 2. Subtract, we get 1. 1 times 1 is 1. Subtract, we get a negative 4. 1 times a negative 4, negative 4. Subtract, we get a negative 2. And then 1 times negative 2, negative 2. Subtract, and we get 0. All right, so this shows us that 1 is a 0. At the most, we will have 4 zeros because that is my power. One of the nice things about doing this is once you find a 0, you can continue and pick up from where you left off. Part of the trick is sometimes you could have a double root, so maybe 1 works again, or maybe it's a different number. So I'm looking at these. I might want to try negative 1 now. So I'm just going to try negative 1. And I'm just going to continue from here. Now, I can also start over, which I'll show you both. But if negative 1 works, I'll get a 0. And the same thing will work if I start here. So I'm going to try negative 1. So we'll bring this 2 down. Negative 1 times 2 gives me a negative 2. Subtract, I get negative 1. Negative 1 times negative 1 gives me a positive 1. Subtract, I get negative 3. And then negative 1 times negative 3, positive 3. Subtract, I get a positive 1. So because I did not get 0, negative 1 is not a 0. So I'm going to try another number. I'm going to try maybe positive 2. So I'll just continue from this row of numbers though. Just want to use that same concept. Sorry. Two, 1, negative 4, negative 2. 2 times 2 is 4. We get 5. 2 times 5 is 10. We get 6. When we subtract 2 times 6 is 12, and we get positive 10. So 2 doesn't work. I'm going to come over here, and I'm going to try negative 2. Again, picking up from the second row of numbers that I got once I found 1 as a 0. Negative 4 gives me a negative 3. 2 times negative 3, positive 6. Subtract, and we get positive 2, and then 2 times positive 2, negative 4, negative 6. Okay, so not 0. So we've tried positive, negative 1, positive, negative 2. We have the halves. There is one thing I do want to try. I want to try 1. See, maybe 1 is a double root. So I want to try 1 again. And then I'll talk about a shortcut to save some time. But you can see it becomes quite a lengthy process, especially when you have a lot of numbers to check. 1 times 2 is 2, and we get 3. 1 times 3 is 3. Subtract, we get negative 1. 1 times negative 1 is negative 1, and we subtract, we get negative 3. So 1 is not a double root. So we've tried all the whole numbers. Now we have to go to the fraction. So I'm going to try positive 1/2. And then I'll show you a calculator shortcut method. So once I get down, so here's the goal. We're trying to get this down to a quadratic. So the first time I found the 0 using 1, that means that x equals 1 is a 0 as a linear factor that comes from x minus 1. Okay? And so I'm looking for the next number. And then what happens is the resulting polynomial, I keep using these numbers. This is 2, instead of x to the 4th, we go x to the 3rd. And then this is 1x squared minus 4x, and then minus 4. So we do know how to solve quadratics. So I need to find one more 0 so that I have a quadratic and I can try to factor or use quadratic formula. So we're going to try 1/2. Again, starting with the 2, 1, negative 4, negative 2. And then we're going to bring down the 2. So what we do, divide by 2 is 1 times 1 is 1, and we get 2. Divide by 2 is 2 times 1 is 1. Subtract, we get negative 3. Divide by 3, we get 3 1/2 times 1, we get negative 3 1/2, which that's not going to give us 0. And then we're going to try one more time with negative 1/2. So that if I've exhausted everything, that means that the other zeros will probably be irrational. And so it looks like this is looking at the rational zeros, and I guess we've made some errors. So we have picking up from 2, 1, negative 4, and negative 2. I'm going to try negative 1/2. So divide by 2 is 1 times a negative 1, negative 1. And we get 0. Multiply, we get 0. We get a negative 4. And then divide by 2, negative 2 times a negative 1, positive 2. And we get a 0. Okay, so this gives me that x equals negative 1/2 is a 0. If we multiply by 2, this gives me 2x equals negative 1, and then we add 1. So the linear factor is 2x minus 1. Okay, so basically rational zeros, we got negative 1/2, and we got x equals 1 for the other one. Okay, so those are our two zeros, 1/2, negative 1/2, sorry, and 0. Now, I mentioned showing another method that could potentially speed this up. So what I do is I have a graphing calculator, online software, graph this function, and you'll look at the graph and see where it crosses the x-axis. So if I turn on the calculator, go to y equal, I'm going to graph this function. So 2x raised to the 4th minus x raised to the 3rd, sorry, That's still in the exponent. I need to come down minus x raised to the third. And then minus 5x raised to the second plus 2x plus 2. All right, so I'm going to graph this. Okay. And it looks like if I zoom in, let's say zoom 2, kind of goes around the middle. Okay, so it crosses, looks like in between -1 and 2. Looks like it crosses between 1 and 0. So this looks like the -1/2 is on the negative side, and then it crossed at -1, and then somewhere in between 1 and 2. So the only the rational ones will show up. If they're irrational, they don't show up. So we're going to have to use quadratic formula to solve the rest, but usually I'll use this, and then I can kind of look at where it crosses and estimate. So like if I was to hit trace, the little cursor is tracing along the line, and it's kind of looking when it hits 0, so that's close to 1, so I would try 1. Over here, it's about 1.5 something. Doesn't look like it's rational. So we might get the square root of something right here, and then same thing over here. So once we get our function down to a quadratic, which is what we have here, remember we started out with x to the 4th. We found 1, 0 right here. So this brought my function down to x to the 3rd. Okay. And then we continued from that point and found another 0, which this brings my function down to x squared. So this means 2x squared. That would be 0x and then minus 4 equals 0. So what we would get is if we were to solve the rest of this, I would add 4 to both sides. Divide by 2. Then that's x squared equals 2. And then we would do the square root. So x equals positive or negative square root of 2. Now that's not a rational number, so that's not one of the ones that we're looking for, but we could find the other zeros if we needed by doing that process. So however, this one says find all rational zeros, write it in the exact form. And so we are only looking for the 2 that we found using those potential zeros. So -1/2 and then +1.